Chapter 10: Motion and Measurement of Distances. Estimation is an integral part of our life. How much food needs to be cooked for the family is estimated by your mother, father, or any other elder at home. How far is your school from your house is estimated by your parents so that they can decide how to send you to school, by bus or bicycle or walking. Introduction. When you stand with your class in the assembly, usually the class line is arranged according to the height of the students. The shorter ones are in the front and the taller ones at the back. What is your position in the class line? Are you among the taller ones or the shorter ones? When you buy a new school bag, how do you decide the size? By estimating the number of books and notebooks you will carry to school every day. When your parents buy vegetables from the market, the vendor weighs it on a weighing scale to estimate how much money he should charge for them. We are estimating things all the time. In the scientific language, estimation is called measurement. All properties of matter can be measured using different methods. To measure length, we use a scale. To measure how hot a substance is, we use a thermometer, and so on. Let us learn why and how to measure different properties of matter. Why do we measure things? Humans are the most evolved species on planet Earth. We live in a society and each of us has different roles to play. Every individual has different tasks to do. To do these tasks, we need to measure things all the time. For example,
to connect two cities by road or rail, the distance between them needs to be measured. To make these roads and rail tracks, various amounts of raw materials that is needed such as iron, wood, cement and sand need to be measured for use.
Farmers measure the area of their fields to calculate the amount of seeds and fertilizers they will need for their crops. Scientists measure the amount of raw materials for chemical reactions aimed at making new substances such as medicines, alloys, paints, clothes, and plastics. Transporters measure the distance between places to further measure the amount of fuel needed by the automobiles to cover that distance. Tailors take measurements before making dresses to fit the size of their customers. Chefs measure the amount of raw materials needed before using them in cooking a dish. The performance of students in a class is measured by conducting tests, quizzes, and exams to help teachers understand how much they have learned.
So we are measuring things all the time. Let us see how we measure them.
How do we measure?
From the examples given above, you can understand that different things are measured in different ways. These measurements depend on the purpose for which we measure and on the properties of the quantity or substance to be measured. Usually, we measure length, mass, volume, current and temperature.
When we measure a quantity, we compare it with a standard value. For example, length is generally measured in meters. Mass is measured in grams or kilograms. Volume of liquid is measured in liters. These standard values are called units. All measurable properties of matter have units, but these units vary from place to place.
In earlier times, mass was measured in tola and sair units in India, but in pounds in UK. Similarly, length was measured in gauge and distance were measured in kos, about 1.8 kilometer, or yojan in India, but in yard and mile in UK. Values of these units differ from each other, which leads to confusion in the exchange of information between countries.
To overcome this problem, standard units for measuring were developed by a group of scientists from all over the world. This was done in a conference on weights and measures in France in 1960. The set of units adopted in this conference is called the SI System of Units, Le Système International, the units in French. The SI units are adopted by people all over the world in all areas such as education, research, and industries. These help countries to exchange information and trade with each other smoothly. The following table gives the basic 7 SI units of measurement. Quantity, unit name, symbol. Length, meter, m. Mass, kilogram, kg. Time, second, s. Temperature, Kelvin, K. Electric current, ampere, A. Number of particles in a substance, mole, mole. Intensity of light, luminous intensity, candela, CD. Sometimes these units are not suitable for measuring a given quantity. In such cases, they can be made bigger or smaller by multiplying or dividing by factors of 10. For example, smaller masses are measured in grams, g. 1 gram is 1,000th part of a kilogram. 1 g is equal to 10 raised to the power minus 3 kg. Similarly, large distances can be measured in kilometer, which is 1,000 times bigger than a meter. 1 kilometer is equal to 1,000 meter. Very small distances are measured in centimeter. 1 centimeter is equal to 10 raised to the power minus 2 meter. Hence, SI units can be changed to suit the needs of measurement. In this lesson, we will learn about how we measure length. How is length measured? Length is one of the most common physical quantities that needs to be measured for various purposes. Length can be defined as the distance between 2 points. Measurement of length is done in 2 ways. One is to know the dimensions or size of an object. For example, length of a book, length, width, and height of a room, and so on. The other is to measure the distance between 2 points. For example, the approximate distance between Delhi and Mumbai is 1400 kilometers. Since ancient times, length has been measured in different units. Some of these units were as follows. Handspan. It is the distance between the tips of the little finger and the thumb of a hand when it is stretched. Cubit. It is the distance between the elbow and the tip of the middle finger of hand. In ancient Egypt, cubit was used as a unit of length. Footsteps. Distance between the 2 feet when a person takes a step. Ancient Romans used this as a unit of length. You can understand that these units have different values for different people because the size of a hand or a foot varies for different people. So, if the length of a table is 7 handspans with your hand, it could be 5 handspans with your father's hand. In 1790, the metric system was developed in France. The unit of length was named meter, which is derived from the Greek word metron, meaning a measure. A meter was a portion of the distance between the North Pole and the equator along a particular meridian passing through France. The unit of volume was derived from the unit of length. Also, larger and smaller multiples of these units could be created by multiplying or dividing by the powers of 10. Thus, this system was a decimal system because conversions could be done by shifting decimal points. Gradually, the metric system was adopted by many countries because it was scientific and simple. In modern times, this system has evolved into the SI system of units, which is now universally accepted. The SI unit of length is meter. It is useful to measure short lengths and distances. To measure very short distances, units like centimeter, cm, and millimeter, mm are used. 1 meter is equal to 100 centimeter. 1 centimeter is equal to 10 millimeter. For measuring large distances, kilometer, km is used. 1 kilometer is equal to 1000 meter. The devices used for measuring small lengths are measuring tapes or meter rods. You measure length with the help of a 15 centimeter ruler or a 30 centimeter ruler. You have to follow the correct method to measure the length of a given object. While measuring length, remember to start from the 1 centimeter mark on the ruler. Keep the ruler straight so that it is equidistant from the edge at all points. Keep your eye in front of the ruler at the same level to get the correct reading.
Measuring the length of a curved line or object. The length of a curved object or line can be measured with the help of a string. You can learn this through the following activity.
What is motion? Look around you. You will find many living and non-living things. Are they changing their position? When an object or life form changes its position, it is said to be in motion. But how do we decide whether it has changed its position? The change in position of a moving thing is noted with reference to another thing which is stationary. Let us understand this with the help of an example. Keep a chair in the center of a room and stand about 2 meters left of it. This is your initial position. Now move about 2 meters right of the chair. This is your final position.
Your position with respect to the chair and walls of the room has changed. Hence, you have moved, but the position of the chair has not changed. Hence, it is stationary. Motion is always measured with reference to a stationary point. When you travel in a bus or train, you are in motion with respect to the trees on the roadside, but you are not in motion with respect to the person sitting next to you.
We can define motion as the action of changing location or position. Motion of an object can be defined as the change in the position of an object with time with reference to a stationary point. Since motion is the change in position of an object, it is measured in terms of distance covered by an object in a given time. We see various living and non-living things moving around us. Do all of them move in the same way? Of course not. Different objects move in different ways, some straight, some in a curve or circle, some to and fro, and so on. Let us identify different types of motion. Types of motion. Rectilinear motion. Motion of a body in a straight line is called rectilinear motion. The motion of a car and the motion of dust particles in air are examples of rectilinear motion. Curvilinear motion. The motion of a body on a curved path is called curvilinear motion. The motion of a train changing its direction and the motion of a stone thrown into water are examples of curvilinear motion. Both rectilinear and curvilinear motions are together called translational motion. Circular motion or rotational motion. When a body moves along a definite path in such a way that its distance from a central point always remains the same, it is said to be in circular motion. Motions of a fan and the hand of a clock are examples of circular motion. In circular motion, the body moves in a circular path and different parts of the body move in paths of different radius. For example, when you rotate a keychain on your finger, it moves in a circle and does not change its position. But different parts of the keychain move different distances based on their distance from your finger. Periodic motion. When a body moves in such a way that its motion repeats after the same interval of time, it is said to be in periodic motion. Motions of a fan, the hand of a clock, and the motion of the earth around the sun are examples of periodic motion. Watch the seconds hand of a clock. It is exactly at the same position after every minute. Non-periodic motion. When the motion of a body does not repeat after the same interval of time, it is said to be non-periodic motion. Motions of a moving bus, leaves of a plant, moving people are examples of non-periodic motion.
The motion of a body may be classified into more than one type. For example, when you walk into your school, it is rectilinear and non-periodic motion. The motion on the moon around the earth is rotational and periodic motion. Story of transport. Motion is one of the characteristics of living beings. Plants cannot move from their position, but their parts move in different directions. Animals move from one place to another for various reasons, such as finding food, looking for mates, and escaping from predators. Motion is very important to humans too. Human beings move long distances in their lifetime. The need for moving helped them evolve an efficient transport system. In the beginning, humans used to walk from one place to another. Then they started using animals for going long distances and to carry load. They also learned to move across water bodies on wooden logs. Gradually, they developed logs into rafts and boats. The invention of the wheel brought a revolution in transportation. They designed carts and carriages. Then came cars and buses. The next invention was the steam engine, which brought in trains. Then the Wright brothers made the first airplane and humans started traveling by air. Now humans have traveled to the space and the moon through spacecrafts. However, most of the modern modes of transport consume large amounts of fuel. As the fuels available to us are non-renewable, we need to conserve them very carefully. We also need to do research and look for alternative sources of energy which are renewable as well as economical.